Okay, you guys, here is part 2 of day 8 math. Part 2 of day 8 math is asking you to do some multiplication times 3, which, if you know the answers to these questions already and you can do it from memory, awesome. If you don't know the answers, they've given you a number line that you can use. I'm going to show you how to use that number line to solve a question like 5 times 3. And like I said earlier, it's just like skip counting. What I'm going to do is I'm going to make some 3 jumps of 3, because that's my number that I'm dealing with that I notice is the same on every single one of these problems. They're all multiplying by 3s. So I've decided I'm going to jump by 3s. Although keep in mind, I've got 2 choices here, really. I could make 3 5 jumps, or I could make 5 3 jumps. And since every single question here has times 3, they're going to all be 3 jumps. I just figure once I make all my 3 jumps, then I'll be able to use the jumps that I've already made for these other questions. Let me show you what I mean by that. I'm going to start with 5 times 3, and at 0, I'm going to make 1 jump of 3, which takes me to 3. I'm going to make another jump of 3, which leaves me at 6. 3 jumps of 3 is 9. 4 jumps of 3 is 12. And 5 jumps of 3 is 15. So I know the answer for number 3 is 15. For number 4, I need to make 8 jumps of 3. And because I chose to jump by 3, I've already done the first 5 jumps. I'm just going to keep going. 6 jumps of 3 would be 18. 7 jumps of 3 would be 21. And 8 jumps of 3 would be 24. So I just kind of counted off from where I left off at 5. At this point, any question I have here has already been jumped out. Here's what I mean. 5 times 3 is 5 jumps of 3, which leaves me at the 15. 8 times 3 is 8 jumps of 3, which leaves me at the 24. 7 jumps of 3, all I have to do is count. 1, 2, 3, 4, 5, 6, 7. There it is. It's at the 21. I've already made this jump out because I chose to jump by 3s. And then the last one says 4 jumps of 3. So I'm going to count it out. 1, 2, 3, 4. And that leaves me at the 12. So all of my answers have been figured out because I jumped by 3s, and every single one of these wanted me to jump by 3s. I can use the same jumps over and over and over again because they're all jumps of 3. So you're going to go ahead and record your answers for 3, 4, 5, and 6. And then we're going to talk about questions 7 and 8. Questions 7 and 8 are missing a factor. So I have something times 3 equals 30. Well, all you need to do is count by 3 until you get to 30. Well, my number line doesn't go to 30, but we can make it go to 30. Why not? It's stopping at 25, and I'm just going to keep it going by counting more. 26, 27, 28, 29, 30. And then I'm just going to move it down into position. And you can do that with your pencil. My number line needs to stretch out a little bit. So I'm going to stretch my number line out. Now I can make my little arrow. Just extending my number line to go to 30 so that if I don't already know how many 3s make 30, I can figure it out by jumping it. So here we have 1 jump of 3, 2 jumps of 3, 3, 4, 5 jumps of 3, 6 jumps of 3, 7 jumps of 3, 8 jumps of 3. I'm going to do another jump of 3, which will get me to the 7, and another jump of 3, which will get me to the 30. All right? So how many jumps of 3 did that take? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it took me 10 jumps of 3 to make 30, so my unknown is going to be 10. Your turn now with trying to find how many jumps of 3 it takes to get to 18. 18 is right here. So all you need to do is count how many jumps of 3 it took. How many 3's make 18? All right? Moving on to the problem-solving portion. We need to write a multiplication sentence with a symbol for the unknown exercises, for exercises 9 and 10. And I want to underline this part right here. Make a multiplication sentence, because there is always more than one way to do something, but they are specific here. They want us to use multiplication. Okay, so I'm going to look at number 9, and number 9 says, a box of popcorn costs $3 at the baseball game. So I'm going to underline that. A box of popcorn costs $3. And then it says the vendor sells 5 boxes to people in row 22. Now, a lot of people might look at that and say, hey, Mrs. Knight, there are 3 numbers in this problem, so maybe this is a 2-step problem. And I'm going to say, no. And here's why. This is a story about popcorn, how much it costs, and how many boxes got sold. The 3 is important because it tells me how much each box cost. The 5 is important because it tells me how many boxes the vendor sold. The 22 tells me nothing about popcorn and nothing about nothing about how much it costs and nothing about how much was sold. This information right here, the row 22, is what we call extraneous information. It's there just to confuse you and catch you off guard. We don't need it. I don't care what row those people were sitting in. All I care about is how much each box of popcorn costs and how many boxes the vendor sold. Now, the word each never actually shows up in my equation, and yet I keep using it. That's because the word each is actually hidden. A box of popcorn costs $3 is like a fancy way of saying each box costs $3. So because the word each is there but hidden, this is a multiplication equation, which we already knew because they told us we were going to be using multiplication to solve it. So I'm going to go ahead and make myself a math mountain for multiplication, where the total goes at the top and my groups go in the circle, and the number in each group goes in the square. So I'm going back to the story. A box of popcorn costs $3, or each box of popcorn costs $3. Because that is my information for the number in each group, that goes in the square because this is where I put my number for in each group. That's how we do it in my class anyway. And then for the circle, this is the information where this is the circle I put my number of groups in. In this case, my groups are my boxes. Since a box of popcorn costs $3, or each box of popcorn costs $3, I'm going to go ahead and take the $3 and I'm going to put it in this square right here. Or yeah, $3 goes here because each box of popcorn costs $3. I have 5 boxes and my boxes are my groups, so I'm going to put those here. There are 5 boxes, and now I just need to find out how much money was spent in all. When I know the 2 smaller numbers, the factors, and I need to find the product, I multiply. So I'm going to take 5 groups, or 5 boxes, and each box cost $3 for a total of $15. All right, so there's my work for the problem, and here is my multiplication sentence. The second question says, Gloria has a study guide for her math, social studies, and science classes. Each study guide is 7 pages. How many pages of study guides does Gloria have in all? Okay, this Math Mountain is one way you can solve a math problem that uses multiplication or division, right? That's only one way to solve it. I'm going to choose a second way this time. This time, instead of drawing a Math Mountain, instead I'm going to draw a picture. And I'm going to draw a picture of her 3 study guides. There's her first study guide. That's the one for math. Here is her social studies study guide. And here is her science study guide. And each study guide has 7 pages. So inside each one, I'm going to write a 7. This is what we call an equal groups drawing. So Math Mountain is one way to solve a problem, but this way works just as well. When I look at this problem, I know, hey, I've got 7 and 7 more and 7 more. I can solve this by adding. And that is true. But remember, it told us to write a multiplication sentence here. So how do I turn this picture into a multiplication sentence? Easy. How many books did she have? She had 3 books. So I'm going to say she had 3 study guides. And each study guide had 7 pages in it. Now, if you add up all 3 sevens, you'll find your answer for how many oh, I put that in the wrong place. Let's move that up. Sorry, guys. Once you count up your sevens, then you'll have the answer for how many pages does Gloria have in all in those study guides. So give that a try. And remember, one way to solve it, another way to solve it that is equally as good. You can do pictures, you can do Math Mountains, you do whatever works for you. Question number 11. Make sense of problems. Meredith feeds her 3 dogs twice a day. How many times does she feed the dogs in 3 days? Okay, she's got her dogs and she's feeding them 2 times a day. So the question I need to ask myself is, do I really need to know how many dogs Meredith has? Well, the best way for me to answer that question is to go to the part that asks how many. How many times does she feed the dogs in 3 days? The dogs. Now here's the interesting part. Boys and girls, if the story had said, how many times does she feed each dog in 3 days? The number of dogs would be important here. But because I just want to know how many times she feeds them as a group, I really don't need to know how many dogs there are. I think this is another one of those extraneous information problems. Here's why. I'm going to use this method again, this drawing a picture method to show you. She feeds her dogs once, twice, the first day. Then she feeds them once, twice, the second day. Then she feeds them once, twice, the third day. Because she feeds the dogs together, I don't need to separate how much food each dog is getting. She's feeding them together. She's feeding them twice a day. Because when I say twice a day, I mean 2 times a day. I drew 2 circles for every day. 2 circles for the first day because she fed them twice that day. 2 circles for the next day because she fed them twice that day. And then 2 circles for the third day because she fed them twice the third day. I don't care how many dogs she has. She's feeding them all together.